Encryption is the process of scrambling the original meaning of data to make it more difficult for unintended recipients to read. Let's suppose that this Rubik's Cube represents data that we would like to encrypt. This is data that has not yet been encrypted. Data that has yet to be encrypted is known as plaintext. There are two main types of encryption: symmetric and asymmetric encryption. In symmetric encryption, the same key is used to encrypt and decrypt data. I shall now demonstrate symmetric encryption on this Rubik's Cube by performing the moves R', D', a number of times to encrypt the data. The data is now encrypted. Previously, before the data was encrypted, it was known as plaintext. Now that it is encrypted, it is known as ciphertext. Encryption can be broken by trying out every possible combination of moves to uncover the original data. This is known as a brute force attack, but this type of attack takes an enormous amount of computing power and time, possibly more time than the age of the universe. Another way of trying to break encryption is by trying out a list of known weak encryption keys. This is something like trying to guess a weak password. This is why it is very important to set a difficult password through the help of a password manager, perhaps, to secure your data, as it doesn't take much for a modern computer to be able to guess a weak password. A weak password can be guessed in a matter of seconds on modest hardware. This is known as a dictionary attack. Encrypted data, or ciphertext, is meant to only be readable by the intended recipients. Unintended recipients will effectively have meaningless data. And now, I will decrypt the data by performing the same R', D', moves a number of times. Because this has been encrypted with symmetric encryption, I can use the same set of moves or the same key to encrypt and decrypt the data. The ciphertext has now been decrypted and the original meaning has been revealed. Now, the data is meaningful. Now, I will demonstrate asymmetric encryption, also known as public key encryption. I will now scramble the cube in a random fashion. The data is now encrypted with one key. And now, I am going to decrypt it by solving the cube. To solve the cube, I will use the beginner's method. Solving the cube with the beginner's method is like using another key to decrypt the data. Notice how the data was scrambled with one key and decrypted with another key. The ciphertext has now been decrypted and the original meaning is revealed. This is how asymmetric encryption works, where one key is used to encrypt and another key is used to decrypt. Asymmetric encryption is also known as public key encryption because there are two keys, a public key, which is shared with everyone, and a private key, which is kept to yourself. Symmetric and asymmetric encryption are both valuable tools in security. However, that is not to say one is better or worse than the other. Symmetric encryption is faster to process and requires less processing power, but it is less secure, as if the key were to be compromised, anything that is encrypted with that key can now be decrypted. In practice, symmetric and asymmetric encryption are both used concurrently to enhance the security of data. This is how symmetric and asymmetric encryption works.